Okay, so this is a problem from the last page of the week 14 notes, uh, and it is to determine the uh, stability and also draw the phase plane of this guy. So I've already taken the liberty and drawn the coefficient matrix, and now what I'm going to do is I'm going to find my eigenvalues. So to find your eigenvalues, you use lambda squared minus a plus d lambda plus ad minus bc equals 0. So I'm going to plug my values into here. Sure you can see. Yeah, you're good. And we got lambda squared minus a plus d is -1 plus -1 is -2 minus -2 is +2. So +2 lambda plus we got a times d, which is -1 times -1, which is 1. And then we got minus bc. B times c is -16 minus -16 is +16. We got 1 plus 16. This all equals 0. So 1 plus 16 is 17. 17. And we're going to need to do the quadratic formula for this. So what we have is lambda equals negative b. B is 2, so -2 plus or minus the square root of b squared, which is 4, minus 4a. A is 1. C is 17. Divided by 2a. A is 1, so divided by 2. Now, I've already done the math for this. This equals -64. See that good? Move this a bit. Is that beam of light in your way? I don't know. Should be okay. So, this is -64. Okay. So, the square root of -64 is an imaginary number, and it's 8i. So, this all equals -2 divided by 2 is -1 plus or minus 8i divided by 2 is 4i. 4i, and this equals lambda. So since we have an imaginary number, this means that our it's either a stable spiral, an unstable spiral, or a center. And since it's one of those three and not the others, that means we don't really have to worry about finding the eigenvectors. So I'm not going to worry about it. But we do know that since this is alpha and it's -1, when alpha is less than 0, that means, therefore, we have a stable spiral. Okay, now I'm going to pause you for a second and flip the board around. So we've determined the stability, and now we're going to draw the phase plane. So right now I have a blank plane, and what I'm first going to do is I'm going to determine my null lines. So for our dx over dt null line, which equals 0, we have -x plus 4y. -x plus 4y. Now I'm going to subtract 4y over to here, so minus 4y equals -x, and then I'm going to divide by -4. That's a 4. So this goes away. These negatives cancel, so we got x divided by 4 is our null line. So I'm just going to rewrite that right here. divided by 4. Okay. Now what I'm going to do is we're going to determine our, camera angles, right? How do they work? Okay. So now we're going to determine our dy over dt incline. So for that, we have dy over dt equals 0, which equals negative 4x minus y. All I'm going to do is I'm just going to add y to this side. So we're going to have y equals negative 4x. Okay. So now what I'm going to do is I'm going to draw the null lines on the plane itself. So we have, I'm going to do the dx over dt one first. So when y is 1, that means x is 4. So we got 1, 4. 1, 2, 3, 4. I'm going to put it about here. I'm going to try to condense this a little bit so that you can see a couple iterations of the spiral. And then when y is negative 1, x is negative 4. So right about here. Good. Okay, so this null line kind of looks something like this. And this is dx over dt equals 0. So that means there's no change in the horizontal direction, which means that it's all going to be vertical when the spiral passes this null line. So I'm just going to draw some straight lines to assist with drawing the spiral. Okay. Now I'm going to draw the dy over dt null line. So when y equals 4, x equals negative 4. So when y is 4, 1, 2, 3, 4, x is negative 4. So somewhere around here. And let me put it like right here. Okay. So now when y is negative 4, so down here, x is positive 4. So 1, 2, 3, 4. And it's about here. Or when y is 1, x is, let me reiterate this. When y equals 1, x equals 4. So y is 1, or no, when y is 1, x equals, when y is, oh god. One more time, let me try this. Okay, when y is 4, x is negative 1. Okay, so y is 4, x is negative 1. So right about here. Sorry about that. And then when y is negative 4, x is positive 1. So y is negative 4, x is positive 1. There we go. All right, now I'm going to draw the null line. Kind of looks like this. And this is dy over dt equals 0. So that means that when it crosses this, it's all going to be horizontal. There's going to be no vertical change. So I'm going to draw some horizontal lines. Okay, so we can kind of infer what the graph is going to look like already by the null lines. But just to be safe, I want to find out the derivative at x equals 0 on the positive y side. So x equals 0. We don't exactly know where it crosses on the y-axis, but we do know that it's going to be positive somewhere here, so we're just going to have a positive number for y. So y equals a positive number. Okay, so the derivative dx over dt is x equals 0, so this goes away. So then we have dx over dt equals 4 times a positive number is a positive number. So dx over dt is a positive number. This means that when the spiral crosses right here, it's going to be heading in the positive x direction. Now, we're going to find dy over dt. So when dy over dt, when x is 0, so this is going to go away. So we have dy over dt equals negative times a positive number, which is negative. So that means that dy over dt is going to be a negative number. So that means that it's going to be heading in the negative y direction when it passes through here. So with those two combined together, we know that when it crosses the y-axis on the positive side, it's going to be heading diagonally downward. So I'm just going to draw a couple diagonally downward lines to assist with drawing the spiral. It's kind of like a skeleton. I'm going to erase this junk so that I can draw the spiral. And all of these are going this way, that way. So I'm going to start at my equilibrium point, and we're going to go vertical at this null line, diagonal right about here, horizontal right about here. It's going to come down, and it's going to be vertical again when it crosses this null line, going around, horizontal at this null line, going back up, horizontal at this null line, and then working its way back to being diagonally here. So we know that we already determined that at this point it's going to be headed that direction. So we know that it's going this way here, which means that it's going this way here, and this way here, and this way here, this way here, this way here, this way here. So it's going like this. So not only does this confirm that it is a stable spiral as it is spiraling towards the center, but also we have determined that it is going in a clockwise direction. So what we have here is a stable clockwise spiral. Ta-da!